This is the video for lesson number 14, Writing Piecewise Linear Functions. At the end of this lesson, you will be able to write a piecewise linear function using linear equations and stating the specific domain for each piece of the function. At the top of your worksheet for today's lesson, there's a warm-up. Please write the equation of each function on the line below. So if you take a moment and look at both of these graphs, you can see that both of these represent linear functions. So you need to make sure that you are thinking of the equation that we use to write a linear equation, y equals mx plus b. So remember that you need to determine from looking at the graph what the slope is and what the y-intercept is. So please take a moment, pause the video, and see if you can come up with the equations of both of these lines. Please pause. So with the first linear function here on the left-hand side, we need to come up with our slope and y-intercept. So first I'm going to identify the b value, the y-intercept, because I can see that it happens right at this point at the top of the graph. At this location, the y value, or the y-intercept, would end up being 100. So I'm going to write that down. b equals 100. For the slope, I'm going to see if I can come up with some other points that are on this line. There are many of them. And let's count the rise over the run. So to get from this point here to this one, I need to go down 2 boxes. But notice when we're going down, if we started at 80 and ended up at 70, that means that we're really going down 10. So for the slope, we go down 10, which is negative, and then we run 1 box, and I look at the x-axis, and in this case, 1 box represents half. So over, and I could put 0.5 in the denominator. If you use your calculator and you divide, negative 10 divided by a half, or if you think about how many times a half or 50 cents could go into $10, you would get, in this case, negative 20. So now that we have our y-intercept and our slope, we can write the equation of this line, which then can be written as y equals m, so our slope is negative 20, x, and the b value is 100, so plus 100. So this is the equation of this line. The one on the right, I notice it's a horizontal line. Do you remember the word that we used to help us out with horizontal lines and writing the equations? It was the word oy. With this, it reminds us that we use the letter y to write the equation of this line. It's a special line. So it's just going to be y equals, and it crosses the y-axis at 40. So y equals 40 is the equation of this line. Now let's take a look below at example number 1. Rosa saved $100 to spend on vacation. For the first 3 days of her vacation, she spent $20 each day. Then, for the next 2 days, she spent nothing. Do you see down below in the graph how we would represent that she spent nothing? Notice from day 3 to day 5, her savings is staying constant at $40. Hence, she is spending nothing. After those 5 days, she spent $10 each day until her savings were depleted, which means all used up. So, we have the graph here that represents Rosa's vacation spending. It says here to complete the definition of f, which just means that we are naming this graph that you see here with f of x. I can also see it over here. Remember, that's just a fancy way of really saying y equals. It says to determine the equation that represents each specific domain of the function. For example, what we need to do is come up with the equation of this piece right here. Remember, this is called a piecewise linear function because it has a couple different pieces of lines this one function. So we need to come up with this equation, and we will write that over here. There's no need to write y equals for our equations because they're already over here, and then we're going to come up with the equation for all three pieces. Here we go. So remember, y equals mx plus b is what we use as our guide to help us out. So do you think you can come up with the equation for this first line? Should look familiar. The y-intercept I could see is at 100. And if we're going to do our rise over run, we could see that we're going down 1, 2, 3, 4, which really represents 20 from 80 to 60. And then we're running 2 boxes, which really represents 1 because we are going from 1 to 2. So I can also see here that the slope is negative 20. Now if you look back at the story, it said that for the first 3 days, so day 1, day 2, and day 3, that would represent this whole first piece here, she spent $20 each day. So our slope, we can already determine, should end up being negative 20 because she's spending $20 each day. So our first equation for this piece would be negative 20x plus 100. Now over here where it says domain, we need to specify where this linear function is occurring. Because remember, we're not talking about the entire line. It's only happening over a certain domain. So remember, domain is our x values. So this line here, or this piece, is occurring where x is 0 to where x is 3. We're always going to specify our domains as an inequality. So we have that it starts at 0 and it's going until and including where x is 3. So this linear function occurs where x is 0 to only where x is 3. Let's do the next piece. This horizontal line here, remember the equation for a horizontal line, we use OI to help us out. So it's going to be y equals some number, and in this case, if we look over, it would be 40. So y equals is already here. I'm just going to write 40 on the line. Now y equals 40 is a line that goes on forever, so again, we must specify the domain. Where does that line or piece occur? When I look at my domain, I want to go to my x values, and I see that it is occurring from 3 to 5. So I'm going to write that down here as an inequality. So my x goes from 3 to 5. But this time, remember from yesterday, if it's already closed on the 3, then we have to write it as being open or not equal to for the 3 the next time around. And then we have over here, it will be closed. Okay, that point is included when we get to 5. Let's write our equation for the last piece. Okay, another linear function. And we need to come up with the equation for this one. So, remember we need to come up with our slope and our y-intercept. I'm going to do the slope first because I can't really see the y-intercept just yet. So let's see. We are going down 2 boxes, which is really down 10. And we are running 2 boxes, which is really 1. So the slope here is negative 10 over 1, or we can just say that the slope is negative 10. Now, can you think of a way that we would find the y-intercept? Excuse me. To find the y-intercept, if we continue this line and follow the pattern with the dots, as in going up 2, left 2, we can go like this and see if we could eventually get to where it's going to cross the y-axis. So let's see. There you go. It would cross it at 90. So the b value is 90, and now we can write our equation of this piece. So the slope is negative 10, x plus 90. For our domain, we're going to take a look at the x-axis, and I see that it occurs from where x is 5 to where x is 9. And remember from before, if it's already closed on the 5 here, then we have to have it open on this one, since it cannot be occurring on both. And the 9 will always be closed. So So when we work with our piecewise linear functions tomorrow, you're going to notice this pattern where the first domain is always closed, and then from there on out, it's always going to be open, and then closed. Before we go on to the back, there is another way, and I'd like you to write this down as well, to find the y-intercept. So, if we know that the slope is -10, and we need to find the y-intercept, what you can do is pick any point on the line. So for example, if I pick this point here, 8, 10. Using y = mx plus b, if we need to figure out what b is, that means that we need to plug in something for y, m, and x. Well, we already know the slope is -10. And then for x and y, since I'm using this point here, and it really doesn't matter which point you use as long as it's on the line and you can see it, for x I will plug in 8, and for y I will plug in 10. So let's see. 10 goes here, and instead of x we are plugging in 8, and then plus b. So now I just have this equation here, and if I continue simplifying, I will be able to solve for b. -10 times 8, and then plus b. To get b alone, we just need to add 80 to both sides. And here we have 90 equals b, or b equals 90, which is what we got before by continuing the pattern. So sometimes we are going to have to do it this way algebraically instead of using the graph, and you'll see that tomorrow. So let's go to the back and fill out our notes. So a linear piecewise function is a function that can be represented by more than one function. As you saw in the previous example, there were 3 pieces of lines, where each function corresponds to a specific domain. Let's jot down here that we're also always going to write the domain as an inequality instead of using interval notation. It's just what we typically use. So to write a piecewise function, which we are going to continue tomorrow, you need to know that we are going to write the linear equation for each function. Just like we did on the front, we wrote the equation for each piece. And you also need to specify the domain. So down below I've also included, remember, you must write it or use an inequality when you do the domain. So that is just specifying where that function is occurring. So to identify the y-intercept if it's not on the graph. So remember from this example, it was on the graph, we were able to find it. I mentioned before that sometimes it won't be so easy. So what you're going to have to do is use, just like we did on the front, y = mx plus b. We substituted in the value of m, or the slope, and then we chose one ordered pair, x, y, and also plugged that in, and then we were able to solve for b. Once you have your m, okay, which you're going to end up plugging in, and your b, then you're all set to write the equation of that line. So tomorrow we're going to continue taking a look at some other piecewise linear functions, like you can see in these graphs below. We will be coming up with the equation for each one and specifying the domain as an inequality. Please, at this time, if you have any questions or comments about tonight's video, please jot them down on your worksheet there, and we can review them in the beginning of class tomorrow. Thank you.